Hi guys, today's video is going to deal with a very specific misconception that is perpetuated, unfortunately, by some of our favorite cartoons. So, I'm not the greatest cartoonist, but here's my attempt at drawing a Wile E. Coyote running off of a cliff that he didn't recognize. See, in a typical Wile E. Coyote cartoon, he kind of runs off the cliff and he kind of goes straight for a bit. And then he'll usually stop right about here and he'll kind of look back and realize that he's floating in the air, and he'll think about it for a second, and then all of a sudden, as he tries to make it back to the cliff, he'll suddenly start to fall to his doom. Now, we all laugh at that because we know that Wile E. Coyote can't actually run off the cliff and then float in the middle of air, but too many new physics students think that's exactly what things do when they go off of a cliff. In fact, if you were to poll the average person and ask them to draw the path of a cannonball being launched off of a cliff, they would draw something like this. See, here's the important thing. Most people would draw a period of time where the cannonball is traveling perfectly straight, and then it starts to drop. And unfortunately, that just doesn't make any sense. I mean, if you think about the forces on the object right there, well, a cannonball that's flying through the air has only one force acting on it. I mean, it might have some air resistance, but we're going to ignore that for right now. See, the only force that really matters on the cannonball is the force of gravity. And that force of gravity is pulling the cannonball straight down. That means that the moment the cannonball becomes a projectile, the moment it is free to fly through the air, it has to immediately start accelerating to the ground. Which means that this part, where it's just going to the right and not falling, it's a lie. Now, with things like cannonballs and bullets, we don't notice this because they're moving so fast that it seems like they're not falling, but it's just not true. And so, if we want to really understand what's going on here, we want to really understand projectiles, there's one very basic idea that we have to wrap our heads around. And that is right here. It's the independence of x and y motion, which says that essentially whatever an object is doing in the x direction has no effect on what it's doing in the y direction. Which actually makes it really easy to understand how a projectile works, but most people don't believe that statement. And so that's where they start to get hung up, this being a classic example. So what do we do? How do we actually explain what happens to an object when, let's say, it just gets launched horizontally off a cliff? Well, we can think about the x motion and the y motion independently because they're different. So what's it doing in the x direction? Well, the object in the x direction is experiencing no forces. You can think about what would happen to the cannonball if there was no gravity. Well, it would fly straight out of the cannon at constant speed because there's no forces on it, so it won't accelerate. And so you get a motion diagram like this. This is what the cannonball would do without gravity. It would travel constant speed to the right. Now, and that's basically the x motion of the cannonball, but what about the y motion? Well, the y motion is shown by this diagram. The object isn't moving in the y motion at the beginning. You can think of a cannonball simply being dropped. But once it's dropped, it starts to accelerate toward the ground at either 9.8 meters per second squared or 10 meters per second squared or whatever you want to call it, but at a very specific acceleration. And so since it's accelerating toward the ground, you can see my motion diagram shows the velocity steadily increasing for each second. Okay, so this is a cannonball that's just being dropped. This is a cannonball that's being fired in, I don't know, space, without gravity. So what happens if you fire a cannonball horizontally with gravity? Well, it's just these two things happening at the same time. The x motion is constant speed, unaffected by gravity. The y motion is simply gravity, unaffected by the fact that we're moving in the x direction. And so where the object is at any second is just that it's traveled this far in the x and this far in the y. So the object's actually at this point after 1 second. After 2 seconds, the object's actually right there. After 3 seconds, it's actually right there. And after 4 seconds, it's actually right here. Now this creates this lovely little parabolic trajectory for the projectile. And this is what all projectiles, this is the path that all projectiles travel. The only difference is that some of them are going faster in the horizontal direction than others. The faster it's going, you can imagine that these points start to go this way farther and farther and farther. And so the object travels a greater distance before hitting the ground. But there are some interesting things about this. First of all, we need to realize that, and probably the biggest thing, is that it doesn't really matter how fast you're going this way. Even if you're going faster in the x direction, you're still falling the same distance each second. And so, no matter how fast the cannonball fires, it's actually going to hit the ground in the same amount of time as something that was fired much slower, even as something that was simply dropped. And that's a big misconception too. Now, the calculations for this, they're all based on this idea. So if you don't understand that the x and y motion are independent of each other, you're not going to be able to calculate anything for projectiles. So make sure to do some of the exercises on my website related to this idea. There's some questions on there that will make you really think about what's going on in a real projectile motion situation, and then we'll add in the math so that you're ready to go.